Okay, let's go ahead and take a look at this problem, which we're going to try to approach using George Polya's four-step problem-solving method, which let's read the problem first. So it says train A is traveling at 70 miles per hour to a destination 200 miles away. Train B will leave 20 minutes after train A. Train B will leave from train A's destination and will head in train A's direction. If train B will be going at a speed 3/2 of train A's, how long will train A, how long after train A left will it take before train B arrives at train A's starting point? Around your answer in the nearest tenth of an hour. Okay, so there's a lot going on there. So let's take a look and see what it is that we have to start with. So the very first principle is understanding the problem. So do you understand all the words? In stating the problem, what are you asked to find or show? Can you restate the problem in your own words? Can you think of a picture or diagram that might help you understand the problem? Is there enough information to enable you to find a solution? Let's go ahead and really focus on the first bullet, the second bullet, and the third bullet. So do you understand all the words? What are you asked to find or show? And can you think of a picture? So let's go ahead and see if we can come up with those things. Okay, do you understand all the words? I think it's more of a phrasing issue that we need to think about. Of course, we understand that's miles per hour. I think maybe this is a phrase to look at. Train A will be leaving from train A's destination. So let's try to figure out what that means, but it might be helpful to go to the diagram bullet to think about and heading in train A's direction, going at a speed of 3/2 of. That might be something to think about. Remember, 3/2, the word of means multiplication. So that's something to think about. And the train A's starting point. So what are we trying to find out? That's the other question. That's the other bullet. How long after train A leaves will it take before train B arrives at train A's starting point? So, okay, so there might still yet be some concepts, ideas, phrases that are left not understood, but let's see if the picture, the diagram helps us understand that. Okay, so train A is traveling at 70 miles per hour to a destination 200 miles away. All right, so this is where train A begins, and it's going in this direction. This is 200 miles away, and it's traveling at 70. And I like to do miles per hour this way. That might not be something that comes to you automatically, but I think it may be useful in this case. And this is train A's destination. So this is train A's destination. And I'm using that word because that's the phrase they use here to help us understand what's happening. And then what is train B doing? Train B will leave from train A's destination. So I'm just gonna put it down here so that I can have a different place to work out train B, but let's assume these are the same place. This is train, so this is train A's destination. Now train B is starting, train B will leave train A's destination and head in train A's direction. So this is train A's direction. So it's going this way. So this is, I guess we could say this is train B's destination. I don't know if they use that phrase. Actually, it's train A's starting point. It's also coincides with train A's starting point. Start point. Okay. And now train B will be going at 3/2 of train A. So this is already getting into the next step, I would say. Let's take a look at the next step and see if I can help you make sense of how to approach a problem. So devising a plan, we're not quite there yet, but let's take a look at this. It mentions that there are many reasonable ways to solve a problem. The skill at choosing an appropriate strategy is best learned by solving many problems. So you just have to solve a lot of problems to get good at figuring out how to strategize. And at this point, your experiences with solving problems probably vary from student to student. So making, guessing and checking, making an orderly list, eliminating possibilities, et cetera, et cetera. I think the reason I sort of want to kind of jump into devising a plan, even though maybe we still have some things left to understand about the problem, is because there might be some things that we can already do. In other words, I think we can use a formula to try to understand or solve an equation to try to understand how fast train A is going. So sometimes what needs to happen is that you're going to be kind of bouncing back between this, understanding the problem, and devising a plan. And my larger point is that it may not be a linear process where you are able to figure out, okay, what's going to be my plan and how am I going to approach this. Sometimes you have to start devising the plan and maybe even carrying some of it out before you completely understand it. So let's go back to the problem. Okay, so let's see if we can figure out how fast train B is going. We know it's going 3/2 of 70 miles per hour. So let's figure that out over here. So 3/2 of 70 miles per hour. So we're going to keep the units of miles per hour. And 70 times 3 is 210 over 2. So that's 105 miles per hour. And we could put a 1 on the bottom if we want to. So now we know how fast train, this is train B's destination. So this is train B's start point. And now we know how fast train B is going. That's its speed. So I guess we can put it over here, 105 miles per hour. All right, what are we trying to figure out? if train B will be going at a speed of 3/2 of train A's, how long after train A left will it take before train B arrives at train A's starting point? So I think maybe the next thing that we need to do in devising our plan, so maybe we hit step 1 of our plan and we carried it out, which is over here. But step 2 of devising our plan may be to figure out how long train A will be traveling. And then once we figure out how long train A is traveling, we can figure out I'm backtracking because we may not need to figure out how long train A is traveling. We're really interested in finding out how long train B travels, but adding to it that train B will leave 20 minutes after train A. So we actually have to figure out how long train B will travel in order to get to train A's starting point. Again, there is a cyclical pattern here of solving and making a plan and going back to try to understand what is being asked of you. And that's what I'm trying to demonstrate. So let's try to figure out how long it takes for train B to cover the 200 miles, and then we'll decide if we need to figure out how long train A traveled. But distance, this is a formula. Distance is equal to rate times time, but we're actually interested in, so this may be a formula that you're not that familiar with. We're actually interested in time because we want to find out how long it took train B to travel. So time, if I rewrite this formula, is distance over rate. And in this case, our distance is 200 miles. And our rate is 105 miles per hour, which if you do the work, if you remember how to work with fractions, you're going to realize that it's copy and multiply, because this is division, by the reciprocal, which is 1 hour over 105 miles. And the reason I do that is because you can see that the miles cancels out, and then 200 divided by 105 is, let me see if I can pull up my calculator. You might not see what that is. It is 200 divided by 105. And so it's 1.905. 1.905 hours. So almost 2 hours, but not quite, is how long it takes train B to travel from its starting point to the end, except that you need to add the 20 minutes that it waited. And again, I'm working through understanding the problem and devising a plan and carrying out the plan at the same time. And so let's see, so let's call this step 1. This is step 2. And step 3 is to figure out how do I turn 20 minutes into hours? In other words, it's a conversion. So using what I know about dimensional analysis, again, you have to draw on your experience and ingenuity. And right now we'll go back to the George Polya process. But step 3 of my plan is to convert 20 minutes into hours. And so there are 60 minutes in 1 hour. So this is 20 over 60. The minutes cancel. This is in hours. So this is 20 over 60, which is a third, which works out to 0.333 of an hour. Okay. And then step 4 would be to add these two. So you get 1.905 hours. That's how long it took the train to travel all the way across. But then you have to add to it what it waited, because it waited a third of an hour. And that gives me an 8 here, a 3 here, 9, 10, 11, 12, 2.238 hours. And it wants you to answer to the nearest tenth, so we can round that off to 2.2 hours. That's how long after train A left that train B arrives at train A. It was the 20 minutes, so now I'm reflecting, which is the third part of George Polya's method. Looking back, and my looking back is to reflect and look back at what we've done and make sure that it makes sense. We carried out a bunch of mini plans as I was trying to understand the problem. Some of the strategies that we used was a formula, distance equals rate times time, some dimensional analysis to convert units, and drawing a picture. And I think also trying to just be ingenious. I'm not sure how to pronounce that word, but ingenious, I think. Trying to use ingenuity. And so finally, our answer was 2.2 hours. It's kind of hidden, but that included the amount of time the train traveled plus the amount of time that it waited for train, the 20 minutes that it waited. And so hopefully that gives you a sense of, yes, going through all the 4 parts of the problem solving process, but also that it's not a linear process and requires you to rethink and understanding a problem doesn't necessarily come all at once, and you may have to work through it as you try to work through the problem.